All right, thanks for tuning in with New Bold. Yeah, ace that test. So we're here with the chapter 5, 6 practice test. Yeah, 100th period. Whoa. What? Okay, so then, not too bad, not too bad. I think you're going to ace this test. Ace this test. So basically, the first problem here, you're just saying to do f of x equals 4. And so you're just going to go to the function of f and plug in a 4 wherever you see an x. Now don't forget PEMDAS. So that means you're going to do parentheses first and exponents next before you do multiplication. So you can make a mistake there easy on the test, so be careful. So you can't do 3 times 4 is 12 and 12 squared is 144. No, no, no. You have to do the squared first. So 4 times 4 is 16, so 3 times 16. 4 plus 4 is 16 as well, minus 5. 16 minus 5 is 11. And then 3 times 16 is 16, 16, 32, 48. So then we have 48 plus 11, which is 59. Awesome. So there's our answer for the practice test number 1. Now f of x plus g of x just says to add them together. So we're going to go ahead and take f of x, which is 3x squared plus 4x minus 5, and add it with 6x minus 8. Now watch out, if this had said minus, then you'd have to distribute the negative through. But it doesn't, it says plus, so we're okay. Remember to list the highest power first, combine like terms. So we've got, there we go, we've got 4x plus 6x is 10x. So bring down 3x squared, nothing to combine there. Plus 10x, and then negative 5 and negative 8 is negative 13. Nailed it. Okay, so there's number 2, not too bad, not too shabby. Okay, so then use these functions for question 3 through 6. Going to be plugging in and then plugging in again. Compositions. So we're going to go to g of x and plug in a 1. And so 1 plus 2 is 3. And since g of 1 equals 3, we can now plug in that 3 here. So now we're doing f of 3, which is the same as x equals 3. And so now we're going to go ahead and do f of 3. And that's going to be 3 times 3 all squared. And so 3 squared is 9. And 9 times 3 is 27. Is our answer. Number 4 is plugging in the whole function into another function. So we're simply going to take f of x, take f and plug it into g. So take f, plug it into g, and so the x completely goes away and we replace it with the 3x squared. So our answer is just going to be 3x squared plus 2. Bam! And then going the other way around now, a little bit different. So when you're going the other way around, g into f, now you take the whole thing of g and plug it in place of that x there. And so it's going to be 3 times x plus 2 all squared. 3 times x plus 2 all squared. So then you have to distribute and go ahead and distribute that out. So that's going to be 3 times x plus 2 times x plus 2. And so then you have to FOIL that. So x times x is x squared. 2 times 2 is 4. And then 2x with another 2x is 4x. Adding those two together. Getting your smiley face. And then we'll bring down the 3 and distribute that through for our final answer. So our final answer would be 3 times x squared is 3x squared. Plus 12x plus 12 for our final answer. Nice. Now, going and plugging in a negative 2, we do have to be careful there. Let's see. So we're going to take that negative 2 for f, and we're going to plug it right there for f. So it's going to be 3 times negative 2 all squared. So then when you do that, you have to do negative 2 times negative 2, which is a positive 4. And then 3 times And then 3 times 4 is 12. And that's not our final answer. We got to now plug that into G, because we still have to worry about the G there. What's up, G? What's up, G? So we're going to plug 12 into G. And so now when we do that, we're just going to plug it in right there into G. So 12 plus 2, which is 14. Bingo, bango, bongo. Easy peasy lemon squeezy. Awesome. Okay, so then don't forget 30, 60, 90, 45, 45, 90 right triangles and how they work. You can use SOHCAHTOA to check your answer, but it's kind of difficult when it's a radical. Okay, so wow, number 7 is upside down. That's interesting. Let's turn the right side up. Where the hypotenuse is 4 radical 3. And then we have our short leg, we don't know, call it N. And then we have our long leg, call it M. It's good to identify each of these legs and put it so we can see what's going on. And so we're going from the short leg, or the hypotenuse. Don't forget to label the hypotenuse on these. If you don't know which one's short, which one's long, which one's hypotenuse, you're going to get it wrong. So be careful, identify them correctly. So now we're going from the hypotenuse to the short leg. It means we're going to make it smaller, so we're going to divide. And so we're going to divide by, well, the relationship with the short leg and hypotenuse is double. So since we're going the other way, making it smaller, we're going to divide by 2. So we take 4 radical 3 and divide by 2. Radical 3 comes along for the ride. 4 divided by 2 is just 2. So n is equal to just 2 radical 3, because 4 divided by 2 is 2. Cool. Now we're going from the short leg to the long leg. So there's a relationship. A nice one. Whoa. The short leg to the long leg of our relationship of our triangle of making it bigger. How much bigger is it? It's a formula. Times by radical 3 much bigger. So now we take 2 radical 3, which was our short leg, and we times it by radical 3. Nice. And so 3 times 3 is 9, so we have 2 times radical 9. And then the square root of 9 is 3, and so 2 times 3 is 6. And so that means that m, the long leg, is 6, and then 2 radical 3 there. Cool. Awesome. Kind of getting it? So this one is going from the long leg to the short leg. And so we're just going to divide by radical 3 now, because we're going from the long leg, L, to the short leg. So in this case, remember, we times by radical 3, because we're going from the short leg to the long leg. But now we're going to divide by radical 3, because we're going from bigger to smaller, right? Big long leg to the smaller short leg. So we take 9, we divide by radical 3. Now you can't have radical 3 in the bottom. Remember that part. So we're going to times it by radical 3 over radical 3, whatever the bottom is, times it by itself. Radical 6 by radical 6, whatever the bottom is. Just times it by itself, top and bottom. That gives us 9 radical 3 over 3 times 3 is 9. But it is the square root of 9. And then the square root of 9 is 3. And that reduces to 9 divided by 3 is 3. So 3 radical 3 is what the short leg is, which is B. And so the short leg is 3 radical 3. There we go. And then we have trying to find the hypotenuse now. And since this is 3 radical 3, and we're trying to make it go to the hypotenuse now, short leg to hypotenuse, we just double it. We times it by 2. And so 3 radical 3 times 2 is just 6 radical 3. And the radical 3 comes along for the ride. Awesome. Thanks for watching this video. I'm going to do video number 2. Now we can keep going. It's only 8 minutes. Come on, new bone. Okay. Let's try to get through these ones. Okay, so now we're going from, go a little bit faster now. So short leg to hypotenuse. So we just double it, right? And when you double it, that's kind of cool. It means you times it by 2 over 1. The 2's cancel, so actually just be 9. And then going from the short leg to the hypotenuse, do you remember what you times by? Say it. No, you say it. No, you say it. What do we times by? To go from short leg to long leg, we times by the formula, which is radical 3 for 30, 60, 90, short leg to long leg. Memorize it. So our answer for y will actually just be 9 radical 3 over 2. It's kind of a crazy answer there. Awesome. Okay, number 10. 45, 45, 90. So 45, 45, 90 is different. If this is 45, then this is 45, and this is a special right triangle. If this leg is 10, then this leg is going to be the same, 10. Because the legs are the same, just like the angles are the same. Cool. But we did learn that the hypotenuse is also going to have a special formula. It's whatever the leg is, so 10. But, so 10, 10, 10. We're done. No. Hypotenuse is bigger. How much bigger? It's radical 2 times bigger. So B is 10 and A is 10 radical 2. If you don't believe me, ask the dishes. They can sing, they can dance. What? So we can use Pythagorean theorem if you're not sure about that hypotenuse just being times radical 2. We'll show you. A squared plus B squared equals C squared. So that's 100 plus 100 is 200. And then we square root both sides. And then 200 breaks down into 100 times 2. Both still square rooting. And then the square root of 100 is 10. 10 radical 2. Just like I said. There we go. Awesome. 10 radical 2. Cool. So we proved that there for you. Just go 10, 10, 10 radical 2. 11, 11, 11 radical 2. 12, 12, 12 radical 2. You got this. So now we're going the other way now from hypotenuse to the leg, And so instead of times by radical 2, we're going to, you guessed it, make it smaller. So divide, not multiply, divide by radical 2. That means that x is 6 and y is 6. Love 45, 45, 90. Ooh, making it harder. So if this leg is 4 radical 2, then this leg is what? Say it. Say it. Sega. What? Oh. No, 4 radical 2. So that means that y is 4 radical 2. And x is, what do we do with the leg? We take it and times it by what's the formula? Going from the leg to the hypotenuse for 45, 45, 90. Times it by radical 2. Good. That's the formula. Formula. Okay, so 2 times 2 is 4. And so we have 4 times radical 4. And the square root of 4 is 2. And so 4 times 2 then is 8. So then our hypotenuse is 8. Thanks for watching. We'll do unit circles next. I do have a big, long video unit circle, but this will be a quick unit circle video. And then we'll jump to the last page. Thanks for watching and working hard on our practice test. Peace out. Thanks for watching. Ace that test.